Hello, and welcome to Flying Failures, where we'll be looking at the Tupolev Tu-22. The Tu-22 was originally intended to be the Soviet Union's crowning supersonic strategic bomber, presenting performance, armament, and cutting-edge technology that would form an essential equivalent to the British Avro Vulcan and form the basis of a two-pronged attack of heavy bombers supported by fighter escorts, alongside supersonic first-strike bombers that could penetrate deep behind enemy lines in the event of war between the West and the East breaking out. However, the resultant Tu-22 was in fact a highly flawed and deeply troubled machine, lacking both the speed and range promised by the original design, also proving itself extremely difficult to maintain and fly, with numerous crashes being attributed to its name, while the Soviet armed forces were often reluctant to employ the aircraft during frontline skirmishes due to its many problems. The Tupolev Tu-22, designated Blinder by NATO, emerged from a Cold War climate in which the Soviet Union sought to modernize its strategic bombing capabilities in response to the growing threat posed by Western nuclear deterrence and delivery systems, with the early 1950s having seen the Soviet Air Force rely primarily on subsonic bombers like the Tu-4, a reverse-engineered copy of the American B-29 Superfortress, and the more advanced Tu-16. While these aircraft had proven reliable and capable within certain parameters, neither offered the combination of high speed and extended range necessary for the kind of deep penetration strike missions against NATO targets that Soviet planners increasingly prioritized, and with supersonic flight rapidly becoming the new standard, the expectation was that future bombers must be able to evade Western interceptors and air defenses with speed alone. Recognizing the need for technological advancement, the Soviet leadership undertook a major reshaping of its aircraft design institutions, with 1953 seeing Joseph Stalin himself authorize the formation of a new design bureau dubbed OKB-23, led by Vladimir Myasishchev, with this bureau being tasked with developing intercontinental jet bombers such as the M4, which showed promise but failed to deliver a truly strategic reach in practice. At the same time, Tupolev's OKB-156, headed by Andrei Tupolev, refused to be sidelined, with his bureau already producing the Tu-16, a medium-range jet bomber that entered service in large numbers and proved extremely versatile, though again, the Tu-16 could not reach targets in the United States from Soviet territory, and even the proposed turboprop-powered Tu-95, while much longer-ranged, represented a stopgap rather than a supersonic solution. In the mid-1950s, the State Committee for Aviation Technology, soon to become the Ministry of Aircraft Production, launched a competition to develop a bomber that could reach supersonic speeds and potentially replace both the Tu-16 and the M4, with the Tupolev design team under the leadership of chief designer Sergei Yeager first proposing a heavily modified Tu-16 fitted with more powerful engines. Known as the Samolyot 103, this design reused the basic Tu-16 airframe, hoping to leap into supersonic performance by brute force, though flight test data and experience from the development of tactical bombers showed that the proposed upgrades would not allow the aircraft to break the sound barrier efficiently, and Tupolev's team realized they needed to abandon incremental modifications and start from a clean slate. In 1954, they introduced a bold new design dubbed the Samolyot 105, which, unlike its predecessors, was a true supersonic concept from the outset, featuring sharply swept wings, angled between 52 and 55 degrees, that were optimized for supersonic flight, though its most notable aspect was the placement of the engines high on the rear fuselage, flanking the vertical stabilizer, with this arrangement being selected in part to reduce aerodynamic drag and optimize transonic airflow, although it in fact introduced complications for engine maintenance and increased structural stress due to the concentrated weight of the rear. Meanwhile, to reduce the frontal cross-section and improve aerodynamics further, the cockpit was designed for a single pilot in a forward offset position, with the navigator and weapons systems officer seated in separate compartments, one behind and one below, with this approach allowing for a narrower fuselage, but came at the cost of cramped conditions and poor visibility, particularly on final approach during crosswind landings. The control layout was widely criticized by flight crews for its ergonomics, with many essential switches and levers placed in awkward positions that sometimes required the use of makeshift tools such as metal hooks to reach them, while compounding the issue was the downward-firing ejection seats, which meant that successful crew ejection was unlikely at low altitude or during takeoff and landing, making the aircraft particularly dangerous in emergencies. Mechanically, the aircraft employed a low-mounted wing arrangement with wing-mounted landing gear retracting into large fairings, and the streamlined design allowed for efficient high-speed flight, but imposed severe penalties during takeoff and landing, with the aircraft's takeoff run being long and its landing speed being significantly higher than the Tu-16, making operation from shorter airfields impractical. At supersonic speeds, aerodynamic heating caused control rods to expand or deform, leading to sluggish or erratic handling, while additionally, the aircraft had a dangerous tendency to pitch up unexpectedly at transonic speeds or during landing, risking tail strikes. Nevertheless, the production Tupolev Tu-22 would be powered by two RDM-7M-2 afterburning turbojet engines, each capable of producing 24,200 pounds thrust dry and 36,300 pounds thrust with afterburner engaged, while in its reconnaissance configuration as the Tu-22R, the aircraft could reach speeds of up to Mach 1.42 and had a maximum range of 3,044 miles and could climb to a service ceiling of around 43,600 feet. Though the bomber's thrust-to-weight ratio and wing loading were both unfavorable, resulting in sluggish acceleration and a modest climb rate, which in turn limited its tactical flexibility and made it vulnerable to interception. Furthermore, the Tu-22's internal bomb bay was capable of carrying up to 13 tons of ordnance, with standard bomb loads including configurations such as 24 Fab 500 high-explosive bombs or a single massive Fab 9000 bomb, while in its missile carrier configuration, the Tu-22K variant was adapted to employ the Raduga KH-22 cruise missile, a supersonic long-range anti-ship and land attack weapon that was semi-recessed into the fuselage. Defensive weaponry was minimal, consisting of a single 23mm Richter R-23 cannon mounted in a remote-controlled tail turret, with this gun being guided by radar rather than optical systems, as the weapons officer had no direct line of sight to the rear of the aircraft. By the summer of 1957, the first prototype Samolyot 105 had been completed and was transported to the flight test and development base at Zhukovsky, where it underwent final preparations for flight, and after nearly a year of ground evaluations and systems checks, the aircraft made its maiden flight on June 21, 1958, under the command of test pilot Yuri Alashev. This initial flight marked a major milestone, but it also signaled the beginning of a challenging and often frustrating development period, with the aircraft's performance during early flight tests quickly falling short of expectations, and it became clear that the prototype failed to meet design goals for both maximum speed and operational range. Flight testing exposed a series of aerodynamic and handling flaws, with the sharply swept wings, designed to reduce drag at high speeds, compromising low-speed control and making takeoffs and landings especially hazardous, while the aircraft was unstable during approach and landing, with a strong tendency to pitch up suddenly, leading to frequent tail strikes on touchdown, and handling in general was stiff and unresponsive, with the aircraft proving difficult to control, particularly during transitions between flight regimes. In response to these deficiencies, the design team implemented a series of significant modifications, resulting in the improved 105A variant, with this updated version incorporating numerous aerodynamic refinements aimed at reducing drag and improving overall stability, with key changes including a redesigned landing gear system to address the shortcomings in ground handling and adjustments to the airframe shape, particularly around the wing roots and engine nacelles, to improve airflow and structural efficiency. The 105A took to the skies for the first time on September 7, 1959, and although it was still far from ideal, the revised aircraft offered some measurable improvements over the original prototype, enough to justify the commencement of limited production even before official state trials had concluded. Serial production of the Tu-22 began shortly after the finalization of its design and early flight tests, with construction carried out at Factory No. 22 in Kazan, a major Soviet aircraft manufacturing facility with a long history of producing strategic bombers, with the first production standard Tu-22B taken to the skies on September 22, 1960. This was a significant milestone for the Soviet aviation industry, which had been under pressure to match or exceed the supersonic capabilities of Western bombers, and the Tu-22 was formally unveiled to the public at the Tushino Aviation Day Parade on July 9, 1961. Where 10 aircraft participated in a dramatic flypast, signifying its official entry into the Soviet arsenal. However, the reality of the aircraft's performance quickly fell short of the fanfare, and although it was the Soviet Union's first supersonic bomber to enter production, the Tu-22 was beset by operational and technical problems from the outset, with these machines officially entering service with both the Soviet Air Forces and Soviet Naval Aviation in 1962, but frontline experience soon revealed a raft of limitations that made the aircraft unpopular with its crews and commanders alike. The reported issues encountered during takeoff and landing continued to persist, which translated to a dangerously high landing speed that was over 62 miles an hour faster than the Tu-16 it was meant to replace. while the ever-present issue of the aircraft's tendency to pitch up abruptly on landing remained an occupational hazard, and although electronic stabilization aids were eventually introduced to mitigate this behavior, it remained a difficult aircraft to handle throughout its service life. Another major flaw lay in the aircraft's engine configuration, with the Dobrinian turbojets being mounted high on the fuselage at the base of the vertical stabilizer. And while these improved the aircraft's theoretical speed performance, it came at a significant cost due to engine maintenance becoming a logistical headache, requiring special equipment and extensive ground crew effort due to the height and inaccessibility of the engines. Moreover, the aircraft's range, one of its primary strategic attributes, proved underwhelming, as despite its supersonic speed, the Tu-22 lacked the endurance to fulfill its intended role as a long-range bomber, especially in comparison to the older, more versatile Tu-16. Only 15 Tu-22B freefall bomber variants were produced, a figure that reflected growing dissatisfaction with the type even in its early years, and the Soviet Air Forces initially attempted to fill Tu-22 squadrons by selecting pilots from the ranks of elite Tu-16 crews. Though this transition proved difficult, as the Tu-16 was operated by a two-pilot crew, with much of the workload shared, while the Tu-22 required a single pilot to manage an entirely different and more demanding flight regime. Many of the hand-picked Tu-16 pilots failed to complete their conversion training, and this recruitment strategy was later revised to instead draw crews from the Su-17 community, whose experience with single-pilot operation and high-speed flight translated better to the Tu-22's requirements. Faced with the aircraft's mounting operational shortcomings, Tupolev shifted gears to specialized variants in an effort to salvage the program, with the Tu-22R reconnaissance version being the most significant of these, entering service in the same year as the bomber variant, and could be reconfigured in the field to perform bombing missions, offering flexibility that the Tu-22B lacked, with a total of 127 Tu-22Rs being produced, with nearly half allocated to Soviet naval aviation for maritime surveillance and strike support. In response to the growing importance of missile technology in strategic operations, the Tu-22 was further adapted into the Tu-22K missile carrier, designed to launch the formidable Kh-22 anti-ship missile, with this variant entering service in 1968 and played a crucial role in Soviet naval strike doctrine. While other versions included the Tu-22U trainer, distinguished by its raised cockpit for the instructor and lacking combat capability, and the Tu-22P electronic warfare variant used for jamming and reconnaissance. Production of the Tu-22 ceased in 1969, by which point a total of 311 airframes have been built across all variants, though despite its limitations, the aircraft found the niche in several Soviet Air Force and naval aviation regiments, and was also offered to overseas allies, with Iraq and Libya becoming the only export customers, each receiving a small number of aircraft in the 1970s, while a proposed sale to Egypt was rejected by Moscow due to the shifting political landscape in the Middle East after the 1973 Yom Kippur War. Iraq made extensive use of the Tu-22 during the prolonged Iran-Iraq War from 1980 to 1988, with the aircraft featuring prominently in Baghdad's opening salvo when a Tu-22 struck a fuel depot at Tehran's Mehrabad International Airport on the first day of the conflict, with this initial wave of attacks aiming to cripple Iranian aviation fuel supplies. Over the years, Iraqi Tu-22s continued to carry out long-range strategic bombing missions, targeting urban centers such as Tehran, Isfahan, and Shiraz during the so-called War of the Cities, with these aircraft also being involved in the tanker war phase of the conflict, launching attacks on Iranian shipping and port infrastructure near Karg Island. With the capability to deliver massive conventional bombs, including the 9,000-kilogram Fab 9000, Tu-22 crews developed a reputation for executing high-speed, high-altitude toss bombing attacks with surprising accuracy. Though regardless, Iraqi losses mounted, with Iranian F-14 Tomcats and surface-to-air missile systems accounting for several shootdowns, including a high-profile incident in October 1980, when an Iranian AIM-54 Phoenix brought down a Tu-22 near Qom. By war's end, Iraq had lost at least 7 aircraft to combat or operational failure, while the remainder of the fleet was destroyed or disabled by U.S. airstrikes during Operation Desert Storm in 1991, bringing an abrupt end to Iraq's use of the type. Libya also deployed Tu-22s in combat, though with mixed results, with March 1979 seeing a single Tu-22 be dispatched to bomb Mwanza in Tanzania in support of Ugandan forces during the Ugandan-Tanzania War, though this mission failed to inflict significant damage, while in the following years, Libyan Tu-22s saw more frequent use in the Chadian-Libyan conflict. Their missions included cross-border bombing raids targeting rebel positions in Chad and areas of western Sudan, while operations began in earnest in October 1980 and continued sporadically for several years, with one of the most dramatic uses of the Tu-22 coming on February 17, 1986, when a Libyan bomber launched a low-level supersonic attack on N'Djamena in retaliation for French bombing of the Wadi Dom airbase, with this aircraft evading radar detection, delivering its payload with impressive precision, and disabling the airfield temporarily. However, the aircraft suffered a technical malfunction on the return leg and was believed to have crashed, possibly hit by Chadian anti-aircraft fire, while another Tu-22 was destroyed 2 days later, possibly intercepted by French Mirage F-1 fighters or brought down by ground fire, while on August 8, 1987, a Libyan Tu-22 was hit by a captured Soviet-built SA-6 surface-to-air missile during a raid on the abandoned Libyan base at Uzu, and a second aircraft was shot down by a French MIM-23 Hawk missile on September 7, 1987 during another bombing run over N'Djamena. These incidents would mark the final combat operations of Libya's Tu-22 fleet, and by 1992, the aircraft had ceased flying, with a lack of spare parts, maintenance difficulties, and changing strategic priorities, meaning the fleet was gradually abandoned and later replaced by Su-24s. The Soviet Union itself made minimal operation of the Tu-22 in active combat, with its only confirmed deployment occurring in 1988 during the Soviet withdrawal from Afghanistan, with this campaign seeing Tu-22Ps, equipped for electronic warfare, escorting Tu-22 M3 strike aircraft near the Afghan-Pakistani border, disrupting enemy radar systems and reducing the threat from Pakistani air defenses. By the end of the 1980s, the Tu-22 had already been rendered obsolete by the introduction of the Tu-22M, an entirely new design that, despite its designation, bore little technical relation to the original, and by the turn of the new decade, the Soviet Air Force had begun to retire the fleet, while following the dissolution of the Soviet Union, Ukraine inherited a number of aircraft, which were eventually scrapped under arms reductions agreements, with the last examples dismantled by 2006. Ultimately, the Tu-22 had been conceived as a modern successor to the venerable Tu-16, but never managed to achieve a similar level of reliability or versatility, with its most lasting contribution being as a developmental stepping stone towards the far more successful Tu-22M backfire, which resolved many of the Tu-22's critical weaknesses. In the end, while the Tu-22 found some utility in reconnaissance and missile carrier roles and saw sporadic use in overseas conflicts, its operational history was defined more by technical limitations and combat losses than by strategic success, and its legacy remains that of a transitional design, ambitious, flawed, and ultimately eclipsed.